Okay, so get this. We're diving into RF sensing today. But not just any radar. Think giving a robot the ability to see like we do.
Oh, yeah.
Yeah, even in like total darkness.
Okay.
Through smoke,
Wow.
dense fog, you name it. That's the kind of crazy leap forward we're talking about with Panor Radar.
It really is a challenge to what we thought we knew about RF sensing, like all those blurry radar images we're used to.
Yeah.
Panor Radar just blows that away. It gets like LiDAR level resolution, all with radio waves.
It's wild. I was reading the paper from UPenn, enabling visual recognition at radio frequency.
Right.
They just presented this at ACM MobiCom 24.
It's making a big splash.
Yeah, huge splash.
Okay.
But before we get into like all the cool stuff it can do, let's break down how it works.
The real key is the design. It's so simple, it's elegant.
Okay.
They use a single chip millimeter wave radar and rotate it with a motor.
Wait, hold on. One tiny spinning radar?
Uh-huh.
That doesn't seem like enough to make a high-res image.
Uh-huh.
Like, especially compared to LiDAR, with all the lasers and sensors.
That's where the ingenuity is. So as the radar spins, it makes this dense cylindrical array of what we call synthetic antennas.
Okay.
So think hundreds, thousands of tiny antennas working together.
Oh,
It's like a virtual super radar. And that density, that's what lets Panor Radar get such sharp resolution.
okay, so it's spinning, creating this virtual army of antennas.
Right.
But how does that translate into seeing the world in 3D? Like, we need more than just a horizontal view. right?
Exactly. And that is one of the biggest challenges with RF, vertical resolution.
Yeah.
But Panor Radar tackles that head on with smart design and machine learning.
Machine learning and radar. Now you're talking.
So the radar itself has just a few physical antennas in the vertical array.
Uh-huh.
Normally that limits the detail it can get in that. They used a huge data set of both RF and LiDAR scans to train it. It's like a teacher. LiDAR is the teacher.
Oh, interesting.
Showing the AI how to interpret the RF data and extract those finer vertical details. The results are amazing.
I bet. But with all that spinning and the robot moving,
Yeah.
wouldn't that mess up the image? Like, it's got to get distorted.
You
right?
got it. Motion estimation and compensation, they're crucial. Researchers developed this really cool algorithm that uses the Doppler effect,
Okay.
but it's way more nuanced than like your average speed gun.
Gotcha.
It separates the frequency shifts caused by the spinning from the ones caused by the robot's own motion.
Okay, so untangling a whole lot of motion,
Uh-huh.
but how does it tell what's what? Like radar spinning versus the robot moving.
By tracking the reflections from multiple objects in the environment, the like echoes, mapping out every move down to the millimeter.
So it's using its surroundings to like chart a map of its own motion.
Uh-huh.
That's seriously impressive.
It is.
But all this fancy tech has to have a point, right? What's the big picture?
It's that Panor Radar doesn't just make a 3D image. It understands what it's seeing. And that's where things get cool.
Oh, okay.
But there's another layer we need to talk about, the panoramic advantage.
Panoramic advantage.
Mm.
Okay, now you've got me hooked. Tell me more.
Well, remember how we talked about the radar spinning for that full 360 view?
Yeah.
That's not just a feature, it's core to how the machine learning works.
So it's not just processing separate slices of the scene, it's looking at the whole picture.
Exactly. And that's where Panor Radar really stands out. It uses this panoramic data in ways other RFs just can't.
Oh, wow.
But let's get into the specifics of that a little later.
All right, you've definitely got me curious. We'll be back to break down this panoramic advantage and how Panor Radar is using RF to not just see, but understand the world. Stay with us.
It's the way Panor Radar uses that 360 view. That's what makes it so different.
Right.
Like, imagine trying to understand a scene, but you only have snapshots from a bunch of different angles.
Okay, yeah.
You're going to miss stuff, right? Especially if something's hidden or cut off at the edge of the photo.
You're only getting a piece of the puzzle, not the whole thing.
Right. But Panor Radar doesn't have that problem. Its machine learning is designed to use the whole panoramic sweep of data.
I see.
They use some neat tricks, like circular padding.
Circular padding.
It basically lets the AI see things that might be split across the edges of the image.
So instead of treating the edges like a hard stop, it wraps them around like a real panorama.
Exactly. And this panoramic learning, it really helps with accuracy, especially for object detection. Like, in their tests, Panor Radar was way better at identifying objects that were partially hidden or split across the image. Way better than traditional methods.
So it's like giving the AI peripheral vision.
Yeah, like that.
It understands the whole scene, not just bits and pieces. Okay, but let's get to the good stuff. How does Panor Radar actually do those visual recognition tasks? Can it really understand what it's seeing just with radio waves?
This is where it gets really interesting. Panor Radar goes beyond just making a 3D point cloud. It analyzes those points and figures stuff out.
Like what kind of stuff?
Well, for example, it can do surface normal estimation.
Surface normal estimation. That sounds complicated.
Think about running your hand over a surface. You can tell if it's flat or curved or at an angle, right?
Yeah.
That's basically what surface normal estimation does. It figures out the orientation of the surface at every single point.
So it's mapping out the shape and contours of things in the 3D world.
Exactly. And the accuracy with Panor Radar is amazing. The results showed an average error of less than 9 degrees.
Wow.
That means it can reliably tell the difference between, say, a flat wall and a ramp, just using radio waves.
That's incredible. It's like giving robots a sense of touch, even though it's just radar. What else can it do?
Oh, surface normal estimation, that's just the start. It can also do semantic segmentation.
Semantic what?
Segmentation, which means it can classify different areas of a scene based on what they are.
Wait, so you're saying this thing can understand that a group of points is like a chair or a table or even a person?
Yep, that's exactly it. They train the model on a huge data set with tons of labels, teaching it to recognize different things: walls, floors, furniture, even people. So now, instead of just seeing a bunch of points, Panor Radar actually understands that those points represent real objects.
This is blowing my mind. So robots can not only see in 3D, they can also understand their surroundings. What could that mean for like the whole field of robotics?
Oh, the possibilities are huge. Imagine a robot navigating a room full of stuff. It doesn't just avoid things, it knows what those things are. It can tell the difference between a chair it can push aside and a wall it can't. Or think about a search and rescue robot. In a disaster zone, it could identify potential victims even in a smoky building where humans can't see.
That's incredible. It's like giving them a whole new level of intelligence. But this is all theoretical, right?
Yeah.
Did they actually try Panor Radar out in real-world situations?
They did. They tested it in 12 different buildings. Some were modern, some were over 100 years old.
Wow.
And they tested it on a bunch of visual recognition tasks, like object detection, semantic segmentation, human localization.
Okay, so they didn't just stick to the lab. This thing's been out in the world. What were the results like?
Oh, really impressive. Across all 12 buildings, it was super accurate and consistent. For object detection, it got an average precision of over 52%. That means it was able to correctly identify and locate objects more than half the time.
And that's got to be even more impressive since it's doing this all with radio waves, not high-res cameras or anything. What about the other tasks? The semantic segmentation and human localization.
So for semantic segmentation, it got a mean intersection over union of 48%. Now, that might not sound like much, but considering how complex the task is and the limits of RF data, it's actually pretty significant.
So it's not perfect, but it's a huge step for RF, for sure. And what about the human localization? That seems especially important for things like search and rescue, right?
You're right, and the results there were very promising. Panor Radar could pinpoint a person's location with an average error of just 12 centimeters in range and less than 2 degrees in azimuth.
So we're talking about pinpointing someone within a room using RF. That's insane.
It is. And it opens up some interesting possibilities for, say, situations where privacy is a concern. Like, imagine monitoring someone's well-being at home without using cameras. RF could be a way less intrusive, more private solution.
That makes a lot of sense. So
Yeah.
this is starting to feel like the future's here. But I have one last question about the tests. You said 12 different buildings. Did the environment itself have any effect on the results?
That's a great question. And one of the most impressive things is that Panor Radar's performance was really consistent across all the buildings. The size, the layout, even the building materials, they didn't really affect its accuracy that much.
So this isn't just some lab experiment that works perfectly in a controlled environment. It can handle the real world with all its messiness.
Exactly. And that's what makes it so exciting. It's a robust, reliable system ready to be used in all sorts of real-world applications.
Well, this has been an incredible deep dive into Panor Radar. It's clearly got the potential to change how we think about RF sensing completely. But before we wrap up, I'd love to get your take on what the future holds for this tech. Where do we go from here?
Well, that's the really exciting part, right? The potential applications are huge. We talked about robotics, but imagine what it could do for self-driving cars.
Self-driving cars, yeah.
Yeah.
Think about all the problems they have now relying on cameras and LiDAR.
Yeah.
Those systems, they really struggle in bad weather.
Oh, for sure. Fog, heavy rain, snow, it can basically blind them, right?
Exactly. But RF signals, they can cut right through that stuff.
That's right.
Panor radars could be a way more reliable way for self-driving cars to, like, see what's around them, no matter the weather.
It's like giving them X-ray vision, kind of.
Yeah.
So they can drive safely even in tough conditions.
That's a huge deal for the whole autonomous vehicle industry.
Yeah.
But what about, like, other fields? Could Panor radar be used for more than just robots and cars?
Oh, absolutely. Think about search and rescue. A drone with Panor Radar could fly over a disaster zone, see through smoke and debris, find survivors, even in places where rescuers can't get to safely.
Wow. That's powerful. And it's not just about finding people, right? It could be used to check how safe buildings are after an earthquake or a fire.
Yeah, that's a good point. Being able to see through walls and map out the insides of buildings, that would be huge for first responders.
Totally.
Help them spot hazards, make decisions about rescue and recovery.
This is wild. It feels like we're just starting to understand what this tech can do. But it can't do everything, right?
Mhm.
What are the limitations?
While like any tech, there are limits. Right now, the range is limited by how powerful the radar signal is.
Uh-huh.
And the visual recognition, while it's impressive, the accuracy isn't quite as good as, say, cameras in every situation.
So there's still room to grow, which is pretty exciting when you think about it. It means there's a lot of potential for more research, more development.
Absolutely. Researchers are already looking at stronger radars, better machine learning models,
Oh.
even making the whole system smaller and more energy efficient. So it could be used in even tinier devices like smartphones or wearables.
Panor radar on a smartphone, huh?
Uh-huh.
Imagine that. All the crazy AR stuff you could do.
Yeah, the possibilities are really endless. As the tech gets better, I think we'll see some amazing applications.
This has been a mind-blowing look at Panor radar. Really shows how RF sensing is changing. It's like we have to rethink what's possible now.
Totally agree. It's a testament to human ingenuity, and how tech can change our world.
Absolutely. This has been an awesome deep dive. I'm so impressed with the people behind this breakthrough. It reminds us that we're living in a time of incredible advancements. The future is wide open. Thanks for joining us, and until next time, keep exploring, keep asking questions, and keep diving deep.